Well, good
All
morning
right,
or
I
good
can hear you,
afternoon.
Steve.
Well, thank you. Good morning or good afternoon, everyone, depending on where you live. As we said, my name is Brad Llewellyn, and I focus on something known as data science enablement, meaning I take organizations and individuals and I really help them unravel what is data science, and more specifically, help them lay out a plan for how they can get from where they are to where they really want to be. So absolutely, thanks for coming to this webinar today. We're here to talk about a topic that I really love, and that's Azure Machine Learning Studio. So throughout this presentation, we're going to spend a few minutes talking about some basics in the slides, and then the rest of the time is going to be live demo. Before we get to that, a little bit about me. Like we said, my name's Brad Llewellyn. I'm a senior consultant at Centelli Solutions in Charlotte. And we focus on exactly what I'm here to talk to you about today. We focus on helping organizations build data science teams. I have a plethora of the alphabet soup of certifications up there. I've been in the analytics consulting space for 5.5 years or so now. I've been at Centelli only a month or two. If you like what you see today and you want to reach out, I blog at Breaking BI. You can also find me on Twitter and LinkedIn. I blog a lot about Azure Machine Learning Studio and Azure Machine Learning Workbench and those sorts of things. So if you want to learn more, that's a great place to go and find more information. I'm also the organizer of a local BI group here in Charlotte called the Charlotte BI Group. So if you live in Charlotte, please stop by. First Tuesday of every month, we have talks ranging from Power BI to Azure Machine Learning to SQL Server to basically anything Microsoft data related we talk about. I'm also a frequent member of PASS as well, so you'll likely see me around these groups and PASS Summit and SQL Saturdays as well. I want to give a thanks to the Business Analytics group for having me. It's groups like this that really allow us to get together and talk about the things that interest us. I'm obviously preaching to the choir here because all of you already know about PASS, but I really highly emphasize that if possible, get involved with PASS. I know that a lot of the user groups are looking for speakers to come and talk about any subject that's passionate to you, as well as looking for people to volunteer to help them run the groups and organize speakers and that sort of thing. Also, I know that your local user groups, as well as SQL Saturdays and PASS Summit, are always looking for volunteers and speakers as well. So if you're looking to get involved and advance your career, that's a great way to do it. Before we spend a whole talk talking about data science, it probably helps to talk about what is data science. So what we see here is a chart provided by Gartner. It's called the Data Analytics Maturity Lifecycle, I think. And it walks through the steps that most organizations take when they're trying to perform analytics. So organizations will start at the bottom saying, just tell me what happened last week. Who did I sell to? What did I sell? And then as they develop those capabilities, they'll often go one step further and say, okay, I know what I sold last week. Can you tell me why it was lower than expected? Can you tell me why this customer bought from me? Why this customer didn't buy from me? Why did this machine fail? Those are some of the basic diagnostic questions. And then once you get even more advanced, you start asking questions around what's going to happen next week. Can I forecast next week's sales, next month's sales, next year's sales? And then finally, as you get sufficiently advanced, we get into the area of what can we do to make things happen? What can I do to make these customers buy from me? What can I do to increase my sales for next quarter? What can I do to decrease my cost for next year? Those are the types of questions you can ask. So with this in mind, I like to say that data science is the top 60 or so percent of this. It definitely includes predictive and prescriptive analytics, which we're going to talk about today under the name of machine learning. It also includes some of the more interesting analyses around why things happened, especially as our data sets are getting larger and larger and companies are starting to utilize things like web logs and social media. Being able to answer why something happens is definitely becoming a data science problem. Also, since data science is a huge buzzword, I try not to use it too much, and I'll try not to use it again throughout this talk, but I like to refer to it as advanced analytics because that seems to ring a little bit better in people's ears. So with that, here's basic agenda. We'll start by talking for a couple minutes on what is Microsoft Azure, just to make sure that everybody here is on the same page, as well as why you would want to use Azure Machine Learning. Then we'll dig into our demo. So what is Microsoft Azure? Microsoft Azure is Microsoft's managed cloud. So a lot of organizations have a lot of infrastructure on-prem. They'll have big server rooms full of machines that run different things. You'll have your SQL servers on there. You'll have your VMs on there. You'll have all your other databases. Your networks will be running off of that. Instead of maintaining all of that infrastructure in-house, you can actually use Microsoft Azure to let Microsoft manage all that for you. So you can just tell Microsoft, I need a network, I need it on these IP addresses, I need these number of SQL servers, I need these number of VMs, and then they create it all for you, and they manage the backend. You can do just about anything you want with that. While this is kind of old news at this point, years ago, and some people still believe that the clouds aren't ready for their organizations, the clouds aren't ready for their enterprise. You hear that a lot in like financial and healthcare companies. Simply put, that's just not true anymore. I actually looked it up the other day for a comparison and found that Microsoft has 70 different security certifications for Azure, and they cover virtually any certification you would ever need for your industry. So it is definitely ready for you. And if you're not considering a move to one of the public clouds in the near future, it's very likely your organization will be left behind. So I highly encourage everybody to think about how they can utilize the cloud to change the way they do business. What can we build with Azure? At this point, literally anything. Almost anything you'd ever want to build, you can build in Azure. We won't go too deep into this because we can have an entire talk on it. But I've got a basic flow on the right side showing you how an organization might structure their data assets around Azure. Now, let's get to the more interesting question, why we're all here today. Why should we use Azure Machine Learning as opposed to the 1,000 other data science tools out there, the 1,000 other advanced analytics tools? Before we get to the why, it's helpful to understand what the common data science struggles are. And for those of you that recognize the picture on the right, that's a picture of a guy named Sisyphus. And his job was to push the boulder up the hill. The problem was every time he'd get to the top of the hill, the boulder would fall back down. And he repeated that forever. So that's a pretty good analog for what a lot of organizations are struggling with data science right now. It feels like they get over one hump just to find there's another one right after it. That's just this never-ending battle of dealing with all these different problems. So if we can find a tool that makes some of that easier, that has a lot of value for a lot of organizations. The first struggle that we find a lot of, and this is very true for organizations that are following that maturity lifecycle, they have a lot of data professionals, but maybe not a lot of classically trained mathematicians, is that the tools themselves have these really steep learning curves and they're code heavy. Anybody who's tried to use R or Python or SAS can attest that they're not the easiest tools to learn unless somebody's teaching you. Also, anytime you're doing coding in these tools, anytime you do just actual application development, then testing and optimization become really time-consuming tasks. Also, anytime you're using these tools, when you open up R and say, okay, I want to use R to predict my sales for next month, you have to not only know how to program in R, but you also have to know what statistical techniques are appropriate for that. And there aren't a lot of places that can really give you good insight into that. So a lot of it just comes from having that knowledge beforehand. And finally, some of these tools become quite difficult to productionalize, meaning once you develop an algorithm that really solves your business problem, how do you make sure that your end users can access that? Microsoft SQL Server and Microsoft in general has made a lot of plays in this over the past few years, so it's definitely gotten easier. But depending on your organization and the tools you're using, it can still be quite a challenge. So with these in mind, let's talk about what Azure Machine Learning is, and then we'll move on to the demo so we can show how it kind of approaches a lot of these struggles. First, Azure Machine Learning Studio is what's known as a cloud computing software as a service. At no point throughout this demo will you see me spin up any hardware, will you see me have to deal with configurations or anything like that. All I have to do is sign up, and Azure takes care of everything else. That's software as a service. That means I just bring my data, and everything else magically works. Also, we have a lot of the popular, well-documented algorithms here. We won't look at Microsoft Docs, but I've spent a lot of time reading through Microsoft Docs over my career, and it is amazing the amount of information they really pack into there. Comparing Microsoft Docs or TechNet or MSDN to some of the R help or some of the Python help, it's night and day, the difference in documentation. Also, it's a tool that's really easily accessible to data professionals, and that's what we'll see a lot of throughout this demo. One of the reasons for that is because, as you're going to see today, I'm not going to write a bit of code. I'm not going to write any code at all today. And that's because I can utilize the code-free GUI that comes with Azure Machine Learning Studio. So just like, for those of you that might be familiar with tools like SSIS or Alteryx, it's got that same drag and drop interface, and we'll see that. Finally, it easily integrates into enterprise data structures using APIs. And at the end of this talk, you'll see me spin up an API, and it'll take me less than 2 minutes to do that. And I am by no means an API expert. I'm a data professional, just like I assume most of you are. So let's get to the demo. Hop on over to our favorite search engine, whichever one you choose. We can just Google Azure Machine Learning Studio. One of the first links here. This takes us out to Microsoft's website. It tells you what Azure Machine Learning Studio is. Just click Get Started Now. Let me log in through in private browser. I'll use Edge this time. It's already got my credentials saved, so I don't get quite the same experience. Azure Machine Learning Studio. Click Get Started Now. And the first thing we see pop up here is right here in the middle, and in green, it's free. For everybody on this call and all of your friends and everybody you've ever met, Azure Machine Learning is completely free. It doesn't cost you anything to use it on your own. As we can see on the right, there is an enterprise grade version of it. That's $10 a month, the same pricing as Power BI. It's extremely cheap. In fact, I've gone to a number of organizations and had to build what are called consumption plans, where we estimate how much their costs are going to be. And I've never seen anybody need more than 50 or 60 bucks a month for Azure Machine Learning Studio. And that's for the largest of organizations. So it's very, very cheap, because the only people that need licenses in an enterprise scenario are your developers. Business users and whatnot, completely free. So what's the difference between these two? We have this free workspace that everybody can and should go home tonight and download. Or we have the enterprise grade workspace. The main difference there is scalability. You can do just about anything you would want to in the free workspace that you can do in the standard one. The only difference is when you start dealing with large enterprise data sets, millions, tens of millions, hundreds of millions of records, the free workspace is definitely going to slow you down. However, for POCs and whatnot, small at-home data sets, there's no problem at all using the free data set. So you could click here and sign in. It's not even going to ask for your credit card number. It just wants an email address, and that's it. And you could log in. I've already got mine open over here. I have a paid version, so I get to take advantage of some of the scalability. So this that we see over here, this is studio.azureml.net. This is the Azure Machine Learning Studio GUI. Notice this is on the web. This isn't on my machine. I could easily go home and use my personal computer and access the same stuff. I could use my coworker's computer. Anybody that needs to could log into this workspace and see the same thing I'm seeing right here. If we look around the GUI a little bit, we see experiments on the left side, and that's what we currently have open. Experiments are the main workhorse of Azure Machine Learning Studio. It follows the same flow that you'd think of in a data flow in SSIS. It's data comes in the top, you do some things to it, it goes out the bottom. You can do various different transformations and whatnot in here, and it's got a lot of flexibility for that unfortunately we won't be able to dive too deep into today. But the main purpose of this is to bring data in from one source, build predictive models with it, and then ship results out the other side. Also, we see web services, which we'll talk about briefly at the very end. We also see notebooks. For those of you that are a little bit more familiar with R and Python, you might understand what notebooks are. And Azure Machine Learning Studio has an interface for your more advanced developers to use that. We also have the option of storing data sets here in Azure Machine Learning Studio, as well as trained models. And we'll take advantage of trained models later. But for now, let's look at data sets. One of the more important questions when we're looking at a tool like this is, how do we get data in and out of it? How do we actually use it? So one of the ways that we can get data in is going to data sets and clicking new down here. We can do from local file. If you have data stored on your local machine, you can bring it in this way. It supports a few formats. Mainly, it just supports text formats. It also gives you the option of importing custom R or Python information directly into Azure Machine Learning. And you could use that if you were using some of the more advanced custom R and Python scripts. In our case, we won't use any of that. As a data professional, I do cringe a little when we talk about using CSVs and TSVs to transport data. That's not the only way to get data into Azure Machine Learning Studio. In fact, it's not even my recommended way, but it is an option. And I've seen it useful in a couple of cases. One is when you've got secure environments and you just want one piece of information that doesn't need to be locked down so hard. If you can anonymize that and pull it out in CSV format and just upload it here and not have to worry about the whole connectivity issue. And I've seen organizations also use it just because they want a quick POC and they don't want to worry about having to set up connectivity between their on-premises infrastructure and Azure Machine Learning Studio. With that, there's a better way, and we'll look at it now. We'll skip over the experiment for a minute. We'll come back to it just because I want to show you what import data looks like. So we have import data here. This is one of the modules, and if we look over on the right side of the screen, we see that we have a few different sources over here. So we can take data from a web URL. You'll see that really common in demos and whatnot for bringing over publicly accessible data. You can write Hive queries. So if you have data stored in a big data repository like HDInsight, you can write Hive queries against that and get your data in. You can pull from Azure SQL Database as well as Azure Table and Blob Storage. You can also query Azure Cosmos DB, which used to be called Azure Document DB, and they haven't updated the naming convention here. You can also pull directly from on-premises SQL databases using the data management gateway. The same gateway that you use for Power BI and Azure Data Factory is the same gateway you use here. And finally, if your data lives in a scenario that's not covered here, they have an OData feed provider that you can use to query with any of those methodologies. Also, how to get data out. You can, at any point along the way, export data as CSV, as a few different data types. You can also export data directly out of here, which is another method. Again, here, unfortunately, you can only export to Azure resources. One of the downsides of Azure Machine Learning is it really wants you to have your data in Azure. It really wants you to take advantage of the cloud. With that said, if you're trusting Azure Machine Learning to do your analysis for you, then you obviously don't have a problem with the cloud. If you have a problem and can't have your data in the cloud at all, then maybe Azure Machine Learning Studio is not the right tool for you, unfortunately. With all of this said, none of these are the production use case for this type of tool. In general, you use Azure Machine Learning Studio to create models, and then you productionalize those models using APIs. So the only data that ever makes it up into Azure Machine Learning Studio is the data you use to what's called train the model, and we'll see that in a few minutes. When you productionalize it, you're creating that API that your organization can then embed into their infrastructure. And you can call that from SSIS or any of the other tools that your organization uses to manipulate data. So with that, there are a lot of different ways to get data in and out of this, and we won't spend any more time talking about that. If we go back, we can go back to new experiment again. This is how we would make a new experiment if we wanted to. One of the interesting things here is there are a lot of samples. One of the things that always frustrated me when I was learning, R and Python and whatnot, is that how do you learn R and Python? You got to download a tool, and then it opens you up to a blank canvas. And then you got to find videos on the internet or read articles and copy and paste people's code and whatnot. And it's not a bad way to learn. It's just it always felt a little disconnected to me. One of the things I really love about Azure Machine Learning Studio is that they have these pre-built samples here, and you can open any of these right in Studio. You can just say, hey, I want to learn how to do regression. It shows you the regression experiments. You can click the one that fits your fancy and open it in the Studio, and you will see the experiment created by Microsoft. All along the way, you can see exactly how they build it. And unfortunately, my internet's a little slow right now, so it's taking a minute. So we can see if we zoom in a little bit. Whoa. If we zoom in a little bit, we can follow the entire path all the way down and see exactly what the person who created this experiment, exactly how they solved that problem. In fact, when I was learning Azure Machine Learning Studio, this is exactly how I did it. So for all of you that want to go home tonight and use Azure Machine Learning Studio, which I hope is all of you, this is exactly the way that you'll want to learn. If we go back out to new experiments, there's another really cool thing here. Let's get rid of the regression. There's a button up here that says View More in Gallery. What's that? So this is the Azure AI Gallery. It used to be called the Cortana Intelligence Gallery. You could Google either of those and find this. But they store a lot of different things here. But if we go to experiments, we can see there are, I don't even know how many experiments out here, created by people in the community, just like you, who say, you know what, I solved this problem in a really interesting way. I want the community to know about it. So right here, Marion Drogt created a employee churn experiment, and you could import that right into your Studio and see what Marion did to solve that problem. In fact, oftentimes throughout my career, when customers have come to me with problems that I'm not quite sure how to solve, I'll often look out here in the gallery to get a little bit of inspiration as to how somebody else might approach the problem. So with all of that in the back of our minds, we can see this tool is very, very easy to learn if you're learning it from scratch. With that, let's walk through a quick demo just to see how it works. So if we click on blank experiment, it takes us out to the canvas, which we've seen before. A little bit of explanation. On the left side of the canvas here, we have what are called modules. These are what you'll drag and drop onto the canvas to create your experiment. And on the right side of the screen, we have the properties. This is where you'll configure each of the modules that you drag out here. The first step to any analysis is to bring in your data. So you can bring in saved data sets, either your personal data sets, and I've got a few out here, or we can bring in one of the samples, and they have tons of sample data sets out here for you to use. I like to use this first one here called the Adult Census Income Binary Classification Dataset. Basically, that's a collection of people. Each row represents a person, and it gives you basic demographic information about that person, like age, gender, their work class, where they live, and those sorts of things, and get you to. And it also has a column at the very end called income. So the purpose of this data set is we want to be able to predict those people's income based on their demographic information. The scenario I like to give about this is, imagine that you run a store and people are walking through your door, and someone walks in your door, either brick and mortar, physically walking in the door, or you're an e-retailer and they log into your website. You collect this information about a person, and you can tell, hey, how much money do I think this person makes, and therefore what type of product should I advertise to them? Should I advertise the really budget conscious product, or should I advertise the really high-end product? And you can base that decision based on their income, which you can predict if you can build a model for it. And that's what we're going to do over the next 15 or 20 minutes. So before we do that, we need to look at this data. In order to do that, we can right-click on our module. You can do this to any module in Azure Machine Learning Studio. Hover over the one and only output in this case, and click Visualize. Get rid of this for a second. This is the Visualize panel in Azure Machine Learning. It allows us to look at each row in our data set, all the way across for all of the columns. In this case, we've got about 32,000 rows and 15 columns. We don't get to see all of the rows and all of the columns. We get to see the first, I don't know, a couple hundred rows or so, and the first 30 or so columns. If your data set's larger than that, it is going to just truncate it here. So if you want to see specific columns in a very large data set, you might have to limit it down before you visualize. But like we said, we have columns here for age, work class, education, marital status, occupation, race, sex, all of those things. One of the really interesting things about this visualization panel, and why I like it over most other tools, is that it automatically gives us these histograms above each of our columns. So we can immediately scroll across and say, hey, race is really skewed, really imbalanced, as they call it. Capital gain is really skewed. Work class is really skewed. We can see that right away. Also, we can click on any of these columns, like age, and up on the right side, it'll give us some basic statistics about it. So we can see the average, the median, the min, max, standard deviation, all those sorts of things. We can even scroll down and see a larger view of that same histogram. So we can see exactly where the breakdowns are. And we can do this for non-numeric values as well. The only difference is we don't have the means and the medians for string values. So if we scroll all the way to the end of this data set, we have a column here called income. This income column here has two values. It has less than or equal to 50K and greater than 50K. So our goal is to build a predictive model that can predict with the other 14 columns in this data set. If we know these 14 things about you, we want to be able to predict your income. Specifically, we want to predict whether you make less than or equal to 50K or greater than 50K. And we can examine this data set a little further. We can hover over the bars, and you can see there are 24,720 people in this data set who make less than or equal to 50K, and then 7,841 people who make greater than 50K. So with that in mind, like I said, our goal is to create a predictive model. So how do we do that? It's actually only a couple of necessary steps. There's a lot of additional flavor you could do here. You can do all sorts of data cleansing. You can do data manipulation. You can do feature engineering. You can do virtually, the sky's the limit here. About anything you could ever do in SQL, R, or Python, you can do here. In fact, you can even use SQL, R, and Python directly in Azure Machine Learning. We won't do it today, but it's certainly possible. And I've got another talk that goes a little deeper into using those. So with that, we scroll down on the left side to machine learning. We go to initialize model. This is where we talked about earlier, one of the struggles with data science tools is having to have that really good knowledge of statistics beforehand. What if we don't have that knowledge? What if I'm not an expert? What if I don't really know the difference between linear and logistic regression? Can the tool help me figure out which one's right? It can, and this is how it does it. So here, once we click initialize model, notice there are only 4 categories here. So looking at these categories, we have anomaly detection, which is tell me what's strange about this data. I don't know what I'm looking for, but I'll know it when I see it type of thing. You've got classification, which means I know what I'm looking for. Can you help me find it? Clustering, which says, just tell me what's going on in this data as a whole. Tell me, are there 5 groups of people here? Are they 10 groups of people here? What's going on? And then regression, which says, hey, help me predict a numeric value. So in our case, we want classification because we know what we're looking for. We want you to tell us whether our person makes less than or equal to 50K or greater than 50K. And we already have those labeled in our data set. So with that, we go into classification. And this basically breaks down to 2 more categories, the multi-class algorithms and the 2-class algorithms. In our case, we want 2-class because income only takes two distinct values, less than or equal to 50K and greater than 50K. In most production use cases, when I'm using this for customers, it's so fast and easy to drag and drop all of this that I'll actually use all of these. There are 15 different combinations. And in that more advanced talk I mentioned earlier, I go over the recommended way for handling this. In our case, I'll just use my favorite, and that's two-class boosted decision tree. We drag that out. For those of you that follow in some of the machine learning circles, two-class boosted decision tree is generally one of the more well-respected algorithms because it may not always be the best algorithm, but it's always close to the best. It's very robust and it generally provides very good estimates, almost no matter what your problem is. Some of these other algorithms are more narrow in their application, but all of them are useful in certain scenarios. For us, we'll just drag two-class boosted decision tree out here. And that's the type of model we want to train. But this model's not trained yet. It's an empty math formula. It's a math formula waiting for us to give it our real data. So in order to do that, we need to do what's called training. So we type train model. There's a module for that. And it wants two inputs. If we hover over these inputs, it says it wants an untrained model and a data set. Well, I know I've got a data set here. If I hover over my data set, oh, it gives me green. Everything always goes to green, making it very easy. I have an untrained model over here. Again, goes to green. So now I've connected it. It's still yelling at me because it wants something else. I click on it, and over on the right side, it says it wants a label. A label is what you're trying to predict. So in this case, I can launch the column selector. And this column selector is really cool. It allows us to make rules if we would like. So for anybody who's ever had to write a SQL query that says, give me all of the numeric columns in a data set or something like that, that's a nightmare to do in SQL. You'll likely just end up doing it by hand. Whereas in here, you can just say, hey, include all column types of numeric or things like that. So it does make it a little bit easier to churn through very large data sets. In our case, we're just going to do it by hand. Our label here is income. So drag income out there, click OK, goes away. We just click the run button, the wheel will spin a little bit, and it'll run very quickly. This is a small data set in a very fast model, so it doesn't take a whole lot of time. Once it's done, like I said, you can visualize just about anything. So right-click, visualize. And here we can visualize the trained model. So once that loads, we can zoom in a little bit. For anybody who's not seen this before, this is a decision tree. A decision tree basically works by splitting your data set over and over again until the little segment you're looking at leans heavily one way or the other. So basically, it'll keep splitting the data set until the data set has a lot of people with either less than or equal to 50K or greater than 50K. So if we look at the first node here, and we can click on it, and over on the right side, it'll tell us what the node is doing. It has this interesting column here called marital status, married, civ, spouse. Some of you that may have pretty sharp eyes might have noticed that data set didn't exactly exist in our original data. We had a column called marital status. This is another one of the areas in which I really like the way that Azure Machine Learning Studio operates. So the two-class boosted decision tree algorithm can't use strings. It doesn't understand strings. It needs numbers. So when we fed our data into that, it went, okay, it's feeding me a string value. I need to turn this into a number. So it automatically used a process known as dummy variables or indicator variables or one-hot processing. It goes by a few different names. But effectively what it did was it took that column, marital status, and split it into one column per unique value. So if a person had a marital status of married, civ, spouse, then their value for the marital status.married, civ, spouse column would be 1. Otherwise, it'd be 0. And it does that for every unique value. So let's say there's 8 unique values in marital status. Every person in your data set is going to have 7 zeros and 1 1. So if we look at this, the predicate here, or the rule for splitting, says that if marital status, married, civ, spouse is less than or equal to 0.5, since it can only take 0 or 1, that means is it equal to 0? If it's equal to 0, that means it's false. So this really asks, is this person not married? Do they have any value other than married civ spouse? If we turn on our edges and zoom in a little bit, if this value is true, meaning they aren't married, then all of those records go to the left side. And if they are married, all of those records go to the right side. And it keeps splitting the data set over and over again like that. That's effectively how a decision tree works. I've actually built decision trees in a number of different tools, and this is one of the best interfaces I've ever seen for it. So it really gives us a good way to dig into our model if we want to. In practice, I rarely look at those. I look at the evaluation metrics, which we'll see here in a minute. So we've got a trained model now, and we've looked at our model. So what do we do with it? When you have a trained model, the ultimate goal is to use that model to predict values, right? So that process is called scoring. So if we type in score, there's a score module. Again, I don't really know what goes to what, so it goes to green. But on the right side here, it's asking for another data set. In machine learning, you often want to test your model, meaning that you train a model, you want to know how good it is. Is this good enough, yes or no? In order to do that, you have to train and evaluate your model. And you generally don't want to do those using the same data set. For instance, imagine you are the model here. Imagine your brain is the model. You have people walking in the door, and you're trying to predict whether or not they have whether or not they make less than or equal to 50K or greater than 50K. The more people you see, the better you get at predicting, hopefully. However, would it be fair if I showed you a person, told you how much that person made, and then later on asked you if you knew how much that person made? You're not actually predicting at that point because you already know, because you've already seen that person. So in general, you want to show that new records. I want to show you a new person and ask you to predict their income. Well, that's called a testing and training split, and it's really common in machine learning. And the way it's often done is just by splitting your data in two parts. I'll give us a little more space here. So we take our raw data and we want to split it in two parts. We have a split data module, as you see, that does that. And we can pick a fraction of the rows that goes into the first data set, meaning the left side. A very common split is what's called a 70-30 split, meaning that 70% of your data is used to train the model and 30% is used to test it. This split percentage doesn't matter a whole lot. In fact, I once had a guy joke during a presentation, oh, why don't you try 10-90? Meaning only 10% of your data is actually used to build your model. The other 90% is used to test it. That's a wild idea. And I tried it just because he wanted to, live there in front of everybody. And it turned out that it didn't actually affect the model all that much. The model wasn't as good as it could have been had we given a little bit more data to train, but it wasn't that bad, which just goes to show that your split percentage isn't all that important. It's important, but it's one of the less important aspects of building your model. Anyway, before we dive too far down that rabbit hole, we've now split our data into two pieces. So we have to retrain our model because now we're not giving it the same data set as before. Instead of giving it all 32,000 records, we're giving it 70% of that. And the rest of the records, the additional 30%, we're going to use that for the scoring. So we just click the run button again. And this will go through its running. Since we're using a saved data set, it would ordinarily cache the results, meaning it wouldn't have to retrain the model. But like we just explained, since we're giving it a new data set, it has to retrain the model because it doesn't know what's in that data set. It takes a second to think. We can see the little clocks here. They'll change in a second. There we go. And it's scoring now. And let's look at what scoring is. So as with everything else, we can visualize the score. We have the same data set. This time, now 30% of 32,000 is about 9,700 or something like that. But we have two additional columns here. What are those two additional columns? If we go over all the way to the right, we have our income column here. We also have this column called scored labeled. This is what the model predicted the value would be. We also have scored probability, which as you get more advanced, that's what your more professional data scientists will often use, the probability instead of the raw label. But in reality, the label is just calculated by whether or not the probability is less than or greater than 0.5, 50%. So we could effectively test our model by looking at the differences between the true income value here and the predicted income value. How often is the model right? And there are a lot of different ways to go into that. Fortunately, Azure Machine Learning has something called Evaluate Model. Drag that out. It wants a scored data set, which we just happen to have. We click the Run button. It's going to churn for a second, but remember, it's not going to have to retrain the model, or rescore that data. All it needs to do is evaluate the model. So while these start out as clocks, you notice they very quickly just turn into check marks because that data is cached. It was just pulling it from memory. Now it's going to evaluate the model. Notice that there's two inputs here, so we could compare one model to another if we wanted to. In this case, we only have one. Once that's done, we evaluate and visualize. And we have a few different options here. We have ROC, precision recall, and lift curves, which your veteran data scientists will know all about these. You can certainly research them on your own time. In fact, I've written blog posts on all of them. But more importantly, we can scroll down and see some numbers here. The one number I like to call out for beginners is accuracy. This number is nothing more than the number of times the model was right divided by the total number of predictions. So this model was right 86% of the time. We could take this to our business users and really ask them, is 86% good enough? There's also more advanced ways to tie numbers to that, to say this model would have made or lost or prevented loss of X dollars, and that makes the decision easier. But that's just one of the things that we learn over time. For now, it's really easy to just look at this and see, hey, I get a base accuracy metric right off the bat. I get precision, recall, and F1, and you can look up what those are, but you don't even have to know how to calculate them. Azure Machine Learning Studio gives you those for free. So with that, let's assume this model is good enough for production. Let's say, yeah, there's a lot more we could have done here. We could have done a lot of feature engineering. We could have done data cleansing. We could have tried models other than two-class boosted decision tree. And in a production use case, I would definitely do that. But here, let's just say that this is good enough. And we want to allow our business users to access this now. We could manually run this from the studio once a week or so, bringing in the new data and exporting the results. You could do things like that. But it's pretty easy to make an API. If we look down here at the bottom, we have two options. We could set it up as a web service. That's what we're going to do. Or we could publish it to the gallery. If you remember the Azure AI gallery we looked at the beginning of this talk, or people are publishing their experiments, we can do the same thing here if we wanted to. Well, for us, we're just going to set up a web service. We want a predictive web service. You can also do retraining web services, which are a bit more complicated. For those of you that saw, we just had some fancy footwork go on the screen. Basically, it replaced our inputs and our outputs with web service inputs and web service outputs. Since this is technically a new experiment, we have to run it one more time just so it gets all of its metadata up to date. Also, if we look here in the middle, we see that our two-class boosted decision tree and our split data and everything is now gone. Instead, it's been replaced with this experiment created on 4/19/2018. This saved the model. So when end users use this, we don't want them to have to retrain the model every time they want to predict for any one person. That would take forever, especially if you have a really complex model that might take a few minutes or a few hours to train. So what it does is it takes that model that we've already trained, it saves it out to storage, and then every time anybody calls this API, it just loads that model, loads the pre-trained model very fast. It's as fast as it gets. Once that model's loaded, it just scores the records that we input, and you can use the API to input a single record. So a single person logs into the website and you immediately know how much they make, or you can do this as like a nightly batch process. You can say, hey, here's the 10,000 people that logged into my website today. Tell me how much they make. You can do that as well. Now that that's run, the last thing we need to do is deploy. We want to deploy using the new portal, not the classic portal. Notice how easy that was. It was one click, or two, I guess. Create the web service and then deploy it. We can name it something. I won't deal with the naming right now. Since I have a paid account, I have the option of choosing a storage account and a price plan. and I already have a price plan set up for this. If you're using the free version, you don't get to configure this. It just uses free versions of all those. And then we click the deploy button. It's that easy. It's going to take a few seconds to process. And while this is happening, what it's doing is it's deploying this out as an Azure Machine Learning web service. You don't need to configure anything about it. And it's actually really easy to productionalize too, especially if you know anything about APIs. And we'll see how to do that here in a minute. Once it finishes all loading up, it takes us out to a new website called services.azureml.net. Before we were on Studio, now we're in the services. Up on the top here, there's a bunch of things we can look at. I always like to go to consume here. It gives us a few different options. One, if we want to test our model here, if we want to see how an end user might work with it, we can actually pull it up in Excel. In fact, one of the ways I find when I'm demoing to customers how Azure Machine Learning works, I often use Excel to do that because it allows us to type in data right there in front of them and see it make the predictions. But if we want to productionalize this as an API, give it to our operations team and let them integrate it. Here's the keys and URIs they would need to do that. For me, I'm not nearly smart enough for that, man. I can't do that. What if it just gave me the code to do it? Fortunately, it does. Down here, it gives us sample code in C#, Python, and R, depending on what language we want to use. For instance, I have productionalized this in C# using in SSIS using C#. This is literally the word-for-word code you would use to productionalize this model. The API is already built. All you have to do is call it from here. You have to replace a few things like the URI and the API key, but other than that, the code's already written for you. So like we said at the start of this, the whole point of this talk was, what if we could make data science just easier? Maybe not easy enough that anybody could do it, but easy enough that a data professional with a little bit of curiosity, a little bit of drive could go out and learn enough to be an effective data scientist, an effective advanced analyst, using the power of an easy-to-use tool. And I hope that's what we've shown today. With that in mind, let's hop back over to the slides for a minute. So with this, the thought I like to leave with is, what are you waiting for? I mean, a lot of people say, I would love to be a data scientist, but I don't have a PhD in math, or I don't have a PhD in computer science. And my response is, you don't have to be. Sure, those people certainly have their place, and there are a lot of problems they can really lend a hand to, but not every problem needs that level of brain power going into it. A lot of our organizations have low-hanging fruit, easy problems that we can quickly solve using a tool like Azure Machine Learning Studio. And that's a lot of what I do with customers, kind of walk them through the easier problems. So in your case, really step one here is just go home and make the free workspace. It costs you nothing but your email address. Step two, use that to find quick solutions to your organization's problems. Somebody wants to predict next week's sales. You can make a model for that really easily. Somebody wants to predict which customers we should target. You can make a model for that pretty easily using the drag and drop interface, in fact. Obviously, once you do that, you're going to become the boss because you're solving everybody's problems, right? And finally, after you become the boss and you've taken your career everywhere you've ever wanted it to go, tell your friends about it. I interact with a group of other Azure Machine Learning Studio enthusiasts, and we honestly believe that probably close to 80% of all organizations' data science questions can be solved in some way using Azure Machine Learning, whether it's a drag and drop interface or the SQL or in Python abilities as well. The only issue here is not a lot of people know about it. There are still people saying, oh, you can't do data science without R, you can't do data science without Python, you can't do data science without a team of PhDs, and that's just not true anymore. So I hope from this talk that we can all go out and understand that data science really is this open field in front of us, and it's the direction that every data organization is going, but it's not quite as hard as everybody seems to think it is. And there are easy things we can do to bite chunks out of that apple right now, and this is one of those. Definitely want to thank you all for coming. Like I said, if you enjoyed what you saw today and you want to learn more about Azure Machine Learning Studio, my blog's there. You can also reach out to me on Twitter or LinkedIn. as well as I give other presentations around to a lot of the other past groups, and there they are. So if you're interested in learning about those, feel free to reach out. But at this point, I'm ready for questions.
Hey Brad, thank you for amazing presentation. Actually, I dazzled when you when you showed that decision making tree, the visualization. It was really amazing. So
Great.
we'll go over the questions one by one. So first question was, is session recorded? Definitely, all of the sessions are recorded, and we will publish as soon as we get the download from GoToWebinar. We'll publish on YouTube. Probably the evening we will publish. The second, and all the questions now relate Azure machine learning for that. So the first question: can we integrate this with SSRS and Azure database together?
Sure. So directly, that question would be slightly difficult to do. If you're using Azure SQL database, Azure Data Factory has a pre-built template for integrating Azure Machine Learning Studio into Azure SQL Database. So you could do it that way, or you can use the C# code we just saw to productionalize it using SSIS, meaning that you do a batch load. You use SSIS to load the prediction results into your SQL database and then report out using SSRS. Unfortunately, SSRS doesn't, at least in my knowledge, have a great way of integrating. On the other hand, Power BI does. So if that's the route you want to go, you can definitely report off of live predictions using Power BI.
The second question is, any advice on how to use Azure machine learning to uncover how the customer responded to various price change for Azure machine learning?
That's a really interesting question. In fact, that's one of the harder questions in all of retail. You can do things like you can look at, if you can quantify your price changes. For instance, say sales last week were X and sales this week were Y, and then look at the average prices for week X and week Y. Then you can draw relationships between the two. You can use different regression techniques to predict sales based on average prices. You can do things like that. You can also look at the price changes themselves as events, and then see before price change, after price change, what the sales were, and then develop models for that.
Awesome. Is there any video tutorial for doing career in data science?
Oh, there are a ton. In fact, that other talk, I don't know if I'm covering it up with my thing. That other talk called "What is a Data Scientist and How do I Become One?" I give there. You can look that up on YouTube. I've done it a few times, and there's a lot of links there to places you can learn more about data science. But that's a very broad question, and the answer is definitely yes.
Okay. So the last question: can we create predictive model for the big data?
Absolutely. So big data is definitely an up and coming trend, and it's not going away. It's only going to get bigger. One of the import data options we had there was Hive query. Hive is a language designed to query off of big data stores. So if you have your data in HD Insight, you can query it into Azure Machine Learning Studio using Hive. With that said, Azure Machine Learning Studio doesn't scale forever. It does automatically scale, like you saw today, but it's not going to churn through a billion records for you, unfortunately. However, HD Insight and Azure Data Lake Analytics and whatnot have their own built-in data science algorithms you can use if your data gets so large that you need those.
Awesome. So there are a few more questions, Brad, but I will send you over the email and we will publish that on our YouTube channel. But definitely thank you for amazing session for Azure machine learning. Do you want to end this session with any quote?
Sure. I mean, I guess I could. Oh man, you put me on the spot there. I guess the only thing I can say to people is definitely There are a lot of people that really like to say that data science is only accessible to the PhDs. And as someone who doesn't have a PhD, I take particular offense at that because data science is accessible to all of us. We just need to understand which tools benefit us. So don't be discouraged by what other people may say. You and your career should not be held back by what other people think. So definitely use the tools at your disposal to do the best you can.
Awesome. Thank you, Brad, and thank you everyone for joining past virtual group session.
Thank you.